itself. But I gotta distribute that -4 first. So this would be like -12 x squared y squared. Okay. So 4 times 3 is -12. And then you get the x squared y squared. And then it'll be -8. 4 times 2. And I like to flip these and put them like in alphabetical order. This is the same as, well, I multiplied by 4, but like, those two things are the same. I like them in alphabetical order. But you don't have to, that's just my like OCD that makes me do that. But there's nothing wrong if you leave it like that. And then I want dy dx by itself. So probably the easiest thing here is move this over there, because then I only have to move one thing. So 9x squared minus 12x squared y squared. If I move that over there, it's positive. And then just divide by, if I go too fast, I feel like I'm going fast. Sometimes I forget you guys are like writing and listening, so just yell at me. So then I would divide by the 8x to the third y, so these cancel. And then over here, that should be the answer, is that right? Oh, so they did, okay. So you would not have to do what they did, but I didn't even know. What they did was say there's an x squared there. You have 3 terms, right? Not like you guys can count. But I have 3 terms, and I could remove an x squared from each one of them. So they did that and ended up with this. But those are equal, and I will take either answer. So did you like think it was wrong? Because you got something different. But it's the same, so you're good. I tried to be very clear about the simplifying directions of the gateway, but again, I don't want to mark anything wrong because simplifying. So if you don't simplify the way I was asking, I'll just go back and say, like, hey, double check the directions. Alright. What else? What else? Glad you guys got so far. I was expecting like number 3. Well, as long as I can sub like further down the road. You know what? 52 and 53, or 51 and 52, I would not put on there.
No.
Because it's not like the inverse out of points.
Yeah.
It's just
I
straight
would
up
like
inverse. And we didn't cover that, and that's fine. So 51 and 52, you can actually cross off. I already wrote it, those are not on there. But the inverse out of point might be on there. Should I do 53 or 54?
Yeah.
Does anybody care which one? 54 looks harder, right? So first of all, I would rewrite this like -x plus 5 to the 1/3. And they're telling me a equals 2. But what they're giving me there is the y value. So your job is to find the x value. Remember, what we're trying to plug into is 1 over f prime of f inverse of x. So first I have to find x. What they're giving me is 1. So, I've got a side quest. So I'm going 2 equals -x plus 5 to the 1/3. So my goal here is because they give me a y value. Well, they give me the x value, but it's an inverse, so it's actually the y value. So I'm plugging that in here, and I'm going to solve that to find my x value, so that I can start using this formula. So if I were to solve this, what do we do first to both sides? I would cube everything, because if I cube that, those go away. And I can cube that and get 8. So that like 3 equals -x if I bring the 5 over, right? my job now is to take the derivative and then plug in the negative 3. Don't forget that's a side quest also, so when like you get your answers on the bottom of the one. So a super common mistake, and I made it a bunch of times myself. You'll do this part and you get like 10, let's say, and then you'll say the answer's 10. But it will be 1 over 10. Don't forget it's 1 over whatever we're about to get. So, y prime, we bring down the 1/3, leave the little guy alone, reduce the power by 1. I'm not done. It's tricky for some people to see. Maybe I still have to multiply by negative 1, right? Because that's the derivative of the inside. That's easy to miss. And then I don't have any reason to simplify, because my whole goal is just to plug in. So I'm going to just plug in right now and not worry about simplifying, because it's wasting my time and I might screw it up. So if I put a negative 3 in there, it's actually a positive 3, right? So 3 plus 5, so this will be 8. So the negative 2/3, which this is a battle for some people. So you do then forget the negative signs there. You do the third root of it first, so you go backwards. So like what number 2 to the third power gave us 8 is 2. Then we square it, 4, then what's the negative do? What's on the bottom? So it's 1/3 times 1/4 times negative 1, which is negative 1/12. Just making sure the answer is 12. Negative 12. So then that negative 12 is not, negative 1/12 is not the answer, right? It's 1 over negative 1/12, which is really 1 times, flip over and multiply, 1 times negative 12. There's a lot going on. First side quest is to find your x value, then you take the derivative and plug in that x value, and then you put 1 over whatever you've got. And I'm done. When I wrote out my work, I tried to I'm like a paid explanation. Show all the steps. Is that okay? Should we just do 53 also, or? So no, like I would say the rule there that applies is no fractions in fractions. It's like a multiple fraction. But like if you brought this up, this is perfect. If you brought this up, I would just say, hey, go back and write it so it's only 1 fraction. I wouldn't worry about it. What else? 7. I wasn't trying to shame you for asking a question on the first page. I just wanted to, I was happy that people got beyond the first page. So I think that, can I erase this or are people still writing? Will you still writing? Are you good? Okay. 7, I'm wondering if the hard part is like the simplification here is really goofy. But I just basically tried to avoid those on the gateway. So what rule is that? Actually, it just says it right there. It's product rule, right? So product rule is big plus give. So the derivative of the first thing. That's just the first power. There's not like a chain there. So actually, I wouldn't use product rule. I'm like looking at it myself at this point. You don't like. I don't say on the gateway use product rule. I say take the derivative. Do you want me to go through it with product rule or like the way I would do it? Or both? Okay. So I'm doing products. It'll be the derivative of the first thing, which would be bring this down and multiply. So that's like negative 25 thirds x to the 2 thirds. You see how I got those numbers? And then the derivative of 1 is nothing. So that's your f prime, and then your g. F prime, g, g prime, and f. So g prime is 6x squared. And f is just rewriting that. And then there's like a whole bunch of ways someone could decide to simplify that, but I don't really have any problem with that like it is. There's no negative exponents. All that's left is multiplying and adding.
We were on the gateway.
So I try to avoid ones like that because it just looks like kind of crappy and like you should do something else, but there's, yeah, you can stop it. So that's the product rule way. If I were to do it the other way, I would probably just distribute. Say, okay, multiply those, so that's negative 10x, and maybe people won't like this next part, but what do you do when you're multiplying exponents with the powers? You add them, so that's like 9/3, right? Plus 5/3, so this is 14/3. And then when I distribute that, it's just 2x to the third. So now I don't need product. The harder part of this one is probably the fractions. So now I don't need product rule. I can bring that down and say, okay, that's negative 140 over 3x. And then if I take 1 away from 14/3, you're taking 3/3 away, so you're taking, so you get 11/3 and plus 6x squared. Believe it or not, those are the same answer. And I would take either one. Lana, is that good? What else? What else?
Are you gonna have tables on the gateway?
Yeah. Should we do it? Did you say 22 or 25 or both? Both? Okay. So if I start with 22, this is like a double chain rule. So like that's your big guy. This would be your in between. This would be your little. So we work from the biggest to the smallest. So what's the derivative of seek? Let me know. It's going to make you memorize it. Sure. Seek 10. The derivative of seek is seek 10. What do I do with the little guy? Leave it. Yeah, that's your specialty, right? So the sec x squared stays in both of those spots. So I can check that one off the list. Then I work to like the middle. So that's sec again. So the derivative of sec is sec 10. And what do I do with the little guy? Leave it. So now I can kind of check that one off the list. And then what do I still have to multiply by? 2x, because it's the derivative of x squared. And then, is there anything in there I can combine? Well, this tan is tanning sec x squared, and this tan is just tanning x squared. They're actually different. So this is the answer. Like, there's nothing else you can do. From there. I mean, that, yeah. Trey, is alright. And then 25, you said? So that's probably it. Like, I would have avoided one of this on the gateway for simplification purposes, but let me still go through it just to make sure you know how to do it. Because this one simplifies. But I want to review, like, it's a quotient rule, it's got trig, so it's a good problem to look at. So that's quotient rule, right? Because you got, variable divided by variable. But on the bottom, within this quotient rule, this is going to be a chain rule where cosine's your big guy and 2x to the 4th is your little guy. So your quotient rule is f prime times g. So f prime is 20x to the 4th. And then you just leave the g alone. Minus. Remember, you're subtracting like this entire second part. G prime times f. So for g prime, take the derivative of the big guy first. The derivative of cos is negative sine. Leave the 2x to the 4th alone, and then multiply by the derivative of that 2x to the 4th. And that I just leave. So that's my g prime, and then that just stays. And on the bottom, you just leave the bottom like it is, and then square. And the simplifying part, like there's a lot of different ways you can do that. I don't have like a rule to say like do this, do this, do this. So I basically just avoided it on the gateway. What other question on how I got to that step right there? Does that make sense? It was like simplifying it. Yeah, and don't. There's not really nothing you can do. Like, I mean, do I want to distribute all that stuff to that? Maybe, but is that simpler? No, it's just making it more garbage. That's good. Alright. Do you have a preference on which table? Back or just like anybody care which table?
I just forgot how to do the tables. I stared at them.
59 or 60? Anybody care? 59. So part one, don't overthink this. That's just like, it's called the addition rule. We don't even really think about it. We just do it like one term at a time. So what's the derivative of f of x? That prime of x. What's the derivative of g of x? G prime of x. And then h prime of 2 they're asking. So I'll just find f prime of 2 plus g prime of 2, which is 1 plus negative 1 half. So 1 half. So like that's technically a rule, the addition rule. But I don't think, if I give you like x squared plus 3x and say take the derivative, I think most of you would just do that, or you were really thinking about like the addition rule. I get it, okay. Well, that's the, they get trickier.
I'm more like, I looked at the table and just kind of forgot what it means, but like, it's more about use the variables to find the derivative, and then you plug in the numbers based off of the chart.
Yeah, but I can still, so number,
Oh yeah, if you do 15, if you go through 59,
do I need to go through 59 part 2?
no, or you don't need to do part 2 or 3.
Well,
Because 3 is what fig plus give,
3 is product rule.
and then the part 4 is the
It's
fig minus give
Yep.
Over g.
I'm sorry, not chain, quotient. Yeah.
And then 5 is the chain. I thought 6 was chain.
The both.
Oh, okay.
So I'm not too worried about part 2. Because that's just f prime minus g prime. You look up at the chart. Is that okay if I skip 2? But 3, 4, and especially 5 and 6, I think are worth going through. So for 3, 5 and 6 are some of the most frequently missed ones, especially on people's first attempt usually. So for 3, your derivative is fig plus give. It actually just kind of says it. So it'll be f prime times g. So there's like your fig, your f prime g plus give. So g prime times f. So if you remember chain rule, it's not, or product rule, it's not too bad. A lot of people they're asking me to find the derivative at 4. And my guess is most of you probably don't write out this step, but just for the sake of like showing you what you're doing, I want to. And then I plug in, the numbers from the chart. So f prime of 4 is 1. G of 4 is 3. G prime of 4 is 1. F of 4 is 4. So then 3 plus 4 is 7. Alright, for part 3 there? Anybody else? Okay. I'll go back and do 4 for sure if anyone wants to, but I want to do 5 and 6 because those are the toughest. Just make sure we get through them. So that is chain rule. Because you have a function within another function. So what's the big guy? The square. Little guy is your f of x. So imagine it was like cosine of x squared. Like it's a similar thing you're doing. It's easier with equations than it is with just like general. So big guy's the 2, so I take the derivative of the 2. Reduce the power by 1, so it's just a 1. So I can write it or not. And then you leave the little guy alone. And we multiply by the derivative of the little guy. That's your chain rule. And then they're asking me for h prime of 1. So look those up. And f of 1 is 1. F prime of 1 is 1. Multiply those out, you can see. Is that okay? 6 is probably literally the most missed question on the initial game. Because it's hard for a lot of people to recognize what rule to use. And then plugging in gets a little tricky also. So that is also chain rule. You have a function within a function. So that's what chain rule is, a function within a function. So what's your outside function? F or G. And your inside function is G, right? Big guy's F, the little guy's G. We see that? Does that make sense? So chain rule says you take the derivative of the big guy or the outside function, and what do you do with the little guy? Leave it. And then you multiply by the derivative of the little guy. Well, what's the derivative of the little guy? G prime of x. So that first step is tricky for some people. And then there's more trickiness on the way. So I want h prime of 1. So that's f prime of g of 1 times g prime of 1. This piece here is tricky for some people. It's not multiplying. This is not like f prime of something. This is not multiplying two numbers together. This is composite functions. So you're going to take, I think the easiest thing to do to understand is to leave the f prime out there and figure out what g of 1 is and put it there. So what's g prime of 1? I'm sorry, what's g of 1? Yeah, 3. And then it's f prime of that 3. So what really happened there is you plug 1 into g, you got 3, and then we're going to plug 3 into f prime. So f prime of 3 is 1, g prime of 1 is 1. So we get 1. So this is a composite piece right here. This definitely throws people off. G prime of 1 is negative 2. Sorry, my process is good. So g prime of 1 is negative 2. I missed that part up at the end. So is the answer negative 2? Questions on especially these two? Those are the most common ones. And then should I go back and do the quotient rule one, or should we move on to a different? You're good. Does everyone want me to do the quotient rule? All right, what else? inverse trig functions. So the derivative of cos inverse starts with a C. What do we know about the inverse derivative? It's negative. Wait, are you correcting me or are you answering my question? Okay, you said it weird. I was like, thought I did something wrong. Okay, so negative 1 over the square root of 1 minus blank squared. That's the derivative of cosine inverse. And then what do I do with the little guy? Keep it and just put it in this spot. So right here is going to go x squared plus 4 to the 1/4.
Are you gonna leave those on the board?
Oh god. You have them in your books. I don't have any reason to. I don't really want people like turning around during the test. So that's just putting that there. But then what do I still have to multiply? The derivative of the little guy, right? So I got to multiply by the derivative of this. So the derivative of this, the thing I just plugged in, the little guy, is a chain. So bring down the 1/4, leave that little guy alone, reduce the power by 1, and then multiply by the derivative of that little guy. And then what I would probably say in the gateway is no negative exponents. But before I do that, I have a question on that stuff. That's the meat of it right there. We're doing this wrong, why do this? So this 4 would just drop to, obviously you got this giant crap on the bottom. And you could leave the 1/4 and the 2 there, that's fine. I'm actually too lazy to write both, so I'm just going to multiply them together and say it's 1/2. You don't have to do that. This negative 1 times 2x will go on top. This 4 goes on the bottom. And then where does this piece go? On the bottom. And what's the new exponent? Positive.
Would you have to do it like that on the gateway, or could you just put that under a 1 and still have it multiply all those things multiplied by each other?
So what I said on the gateway for ones like this is write it as 1 fraction. So like this is not 1 fraction, right? But this is. That's the simple thing I want you to do. Is that okay? Pretty tough. Yeah, I mean that's fair. Others. So I'm going to give you the practice one. This is like what the gateway will look like. And then I'll hand out my answers to them on this sheet of paper that's not blue. So really on the actual gateway, I keep the directions the same. The setup the same, and it's just a problem.
So there'll be 1 here, 1 here, 1 here.
Yeah, so number 1 on your gateway will have the exact same instructions, but probably similar. Remember, similar can mean a lot of different things. Like number 3 is a chain rule question. On my thing, I did it like a chain rule question, but it could have trig. So this is not like a third. That's why I made you the 75 question. That's a third overview. This is more like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 150 151 was not free, but the school paid for it. I'll show you. Yeah. So like I'll open up that assignment. Here's that assignment. So these directions, this is power rule. If I go to like the options, here's all the things I can choose from. And then if I just hit like spacebar, it gives me another problem. And I just keep doing that until I get what I like. This is quotient rule, so I just keep doing it until I get what I like. It's pretty nice. And then yeah, it makes the answer key too. Before this program, teaching this class was a lot more time because I had to make all the answers. I had to do every single